In this section, we're going to be looking at proving lines parallel. So to start off with, we're going to look at a postulate, postulate 3.2, converse of the corresponding angles postulate. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So here we can see that if angles 2 and angle 6 are congruent, then lines L and M are parallel to each other. It's basically the opposite of one of the postulates we learned before, which was the corresponding angles postulate. The next thing we're going to look at is theorem 3.4, converse of the alternate interior angles theorem. The word converse basically means opposite, so keep that in mind when we're learning all of these postulates and theorems. The theorem states that if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So if angle 4 is congruent to angle 6, as we can see in the diagram, and a transversal forms these alternate interior angles, then line L is parallel to line M, and this is basically the opposite of the alternate interior angles theorem. The next theorem we're going to look at is theorem 3.5, converse of the same side interior angles theorem, which is basically the opposite of the same side interior angles theorem. It states that if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. So here we can see that if measure of angle 3 plus measure of angle 6 equals 180 degrees, then line L is going to be parallel to line M. The last theorem we're going to look at for this section is theorem 3.6, converse of the alternate exterior angles theorem. The theorem states that if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So when we look at this diagram, if angle 1 is congruent to angle 7, as indicated in the picture by the red lines, then we can justify that line L is parallel to line M. Now we're going to look at an example of using a proof in order to prove converse of the alternate interior angles theorem. Instead of writing a regular two-column proof, we're going to use flow proof, which uses arrows to show the logical connections between statements. So in this example, we're given the information that angle 4 is congruent to angle 6, and we want to prove that line L is parallel to line M. So to start off, we're going to write what we have been given. So angle 4 is congruent to angle 6, and we can tell that angle 2 is congruent to angle 4 because vertical angles are congruent angles. Now we're going to draw some lines to connect it to the next point in our flow proof, which states that angle 2 is congruent to angle 6 because of the transitive property of congruence. So in a flow proof, you just write the reason underneath the statement. Then we're going to connect that with another line that says line L is parallel to line M. If corresponding angles are congruent, then the lines are parallel. And this proves the converse of the alternate interior angles theorem using a flow proof. In this final example, we're going to have to use some algebra in order to solve. Here we want to look at the value of x for which A is parallel to B. So we can see that we have two same side interior angles. So based on the same side interior angles theorem, we know that 2x plus 9 plus 111 is going to equal 180. So now we can go ahead and simplify, and that gives us 2x plus 120, which equals 180. Now you want to go ahead and isolate the 2x, so subtract 120 from both sides. That's going to leave us with 2x equals 60. And then in order to isolate the x, you divide both sides by 2, and that's going to give us x equals 30. So we know that x equals 30, and in order to find out the angle degree of the upper angle, we plug in the 30 in for x. So 2 times 30 is going to give us 60 plus 9 equals 69 degrees.